Thank you very much, and welcome to the first meeting of the Malmö C User Group, which are you. So, a user group. I know there's a lot of really smart people in this region. Just look at the group right here. And I yelled about this on Twitter, saying, hey, why isn't there a group? And C++ Sweden, which is on Twitter, which has a user group in Stockholm, just make one. I'm like, okay. So here we are. So who am I? My name is Ólafur Waage. Good luck with that. I am a programmer at Ubisoft Massive. I've been there for the last 4 years, and I love everything to do with C++. I am super nerdy in C++. So, the user group itself. This should be about us learning, and this is a great opportunity to practice public speaking. So if you have a talk coming up soon at a conference, or you would just like to practice public speaking, this is the venue, this is the forum. So I can't do this alone. I would need some people to help me. So let's talk over pizza and beer afterwards about who would like to come and help me and join managing this user group, or would like to do a talk in the next meeting. And since I love good questions, from Simon up in the UK, I got 2 C++ badges. So if you ask a really, really nice question afterwards, you get one of these. So we cool? Good. So, did you get that? C++ messages and Uplay. So let's start with Ubisoft. What the hell is that? Ubisoft is a French video game publisher and developer founded in 1986. It's known for such games as Assassin's Creed, ooh, Far Cry, just released number 5 recently, and The Division, which is developed here in Massive along with other studios. So Ubisoft has more than 13,000 employees in 40 studios in 30 countries, and there's 2 here in Sweden. We have the one in Malmö, close to the canal, the big red building, the massive building, if you think of it that way. And one recently opened up in Stockholm, but I don't know where it is in Stockholm. I haven't been there. So what is Uplay then? Uplay is the Ubisoft's PC platform, which means that we offer a game library, downloads for your games, your friends, chatting with them, achievements, etc., etc. A lot of these often called auxiliary features as well. So you would have a game library with all your games you have on them. If you would click on a game, you could go to the game page, click play, or join any of your friends playing, read about news, or cry over how much time you spent playing the game. You then download games, chat with your friends, see what your friends are up to and join them, and be like, oh, this person is doing this thing, I want to do that too, so let's join them. So Uplay is used by millions of users every day, and the size of the games and the development of them requires us to add features fast, and we need to be stable because you can't have this crashing. So we need to be able to develop new features fast. The project itself started about 8 years ago, and as a foundation for the project, Chromium Embedded Framework was selected. It allows us for fast UI development using very common HTML, CSS, and JavaScript. So the idea with the client UI is that it's just a view. It will contain no business logic, it's just a presentation layer. And the C++ backend would feed the data to the view. Seems simple enough. The nice thing about this is we can use any framework on the market. It's the bog standard HTML, CSS, JavaScript. So whatever is the cool new tech, yeah, we could use it. And another cool thing about it is we only want browser to target, us. We don't have to look at how we would work in Internet Explorer because there's only the Chromium framework. And not only that, we don't have to worry about version differences. There's only that one version of the browser. So that's super nice. The Chromium framework initially released in 2009, which then means we were pretty early adopters to this tech. It gives an SDK to programmatically create and control Chrome instances. And examples of applications that use this are Battle.net, Steam, League of Legends, the launcher there, Spotify as well. The downside is it's not a magic solution. It's not something that you click and then you get a Chrome instance. You have to write a bit of code. There we go. There are libraries out there. Electron is one of them, which is used by Slack and Discord. But that abstracts away a lot of basically the utility you have for the library itself. So if you don't want to write quite a bit of code and then lose a little bit of the control, if that's fine with you, you can use one of those libraries. But when we started, they didn't exist. It was only this. So our code is based upon that. A little note about the code we're going to have. It is quite a bit of code that I'm going to show. The main point of that code is for illustration points only. It is our code. It is our setup, but a lot of it has been trimmed to fit onto the slides. And even if it's been trimmed, some of it is a page long. But just, yeah, we'll go through it. And many error checks and log lines have been omitted. So please note. So we have a dream. We always have a dream. Our dream is to do this. When you click a button in the UI, a function like this is called. In any sense, you can bind it. Let's say it's a download game, and we'll use download game as an example throughout the presentation. You click it, it will say you would like to download game number 20. You would create a JSON message. This is the standard JSON object. Put the asset ID in, call a function, send message, which I'll show you later. You'll have a string, message download game, and send in the message. And by doing that in the UI, a C++ function would be called automatically with a struct filled with the data. That's the dream. So clicking here would get us a breakpoint over there. So how do we do this? How do we go from a JavaScript object to a fully formed C++ struct with the data? So I talked about before that CEF gives you a full SDK to create and control your own instance of Chrome. And again, it is a bit of code. So let's go through that bit of code. First, you need to create an application. We create something called the CEF App Handler, and it implements 3 interfaces, the main one being CEF App. CEF App asks you to overload a thing called OnContextCreated. Okay? And when you start your application, you would instantiate and create your CEF App Handler, which is your class, and give it to a CEF execute process. This will spawn a CEF process and instantiate your app handler. By instantiating the app handler, when everything is ready, it will call OnContextCreated. So let's look at that function. What you get in OnContextCreated is you get a browser, get the frame, and you get the context itself. And what we do is we create a function called Uplay UI message. And we pass to it a V8 handler, which I'll go into in a bit. I will then take the frame, get the global object of the frame, and set this callback to the global object. Okay, so now we have a function in the global object. So, yeah. What does that mean? So let's look at send message that I showed before. Send message takes in the message name and the variables you want to send in. And here I have Uplay UI message, which is this function. The global object was the window itself. So now I have attached a function that I created on the C++ end to the window itself, and it's called Uplay UI message. And this will always be there. But we don't access it directly like this. We always abstract it away through a function like send message. So we don't actually call the access the window directly. We just say send message. So this will send the message name, or if it has any variables that I defined before, I will just stringify it. So I'm basically sending a string. So let's try connecting the dots. So we have defined our callback, and we have created the function in the JavaScript. So let's look at our callback from before. I have this V8 handler. What is this V8 handler? The V8 handler is a implementation of a thing called CEF V8 handler. And this is just an execution object. It's an interface with an execute. And when the callback is called on the JavaScript end, CEF knows that this is the object that actually should be called. So when I call this function on the CEF end, it is actually calling this function here. So calling this is then in the end actually calling this. So I have the name of the object itself, the arguments, and the return value, which I can then set. So if you want to run the code directly there, you can. You can say, hey, I know what the object name was. I defined it before. And I know what work I want to do on it. So I can just take the arguments, do the work, set the return value, and then say I'm done. So you can actually run the code here. But we don't want to do that because we have many views. As you saw, we have the chat view, we have the main browser view, we have like the little notification guy that's always hidden in the center, in the taskbar. So what we want to do is we want to send this message to all the clients that might be instantiated because we don't know who is going to want to work on this object. So in the execute, there's some work I've commented out. This function is about a page long, but what we're basically doing is we're making sure that the thing that is being executed is our object. But in the end, I can get the context and I can get the browser that is being used. And on that browser, I can send a process message. The arguments are commented out. It's a pretty long. What I'm basically saying is I'm sending in the name and the object and the arguments. So this is just a wrapper with a known interface, so V8 can call whatever instance you give it. And the instance lives in your app handler. So the app handler I created before, this V8 handler is just sitting there. That's an instance there. So we talked about an app handler. We talked about executing the C++ defined function in JavaScript. But we haven't talked about the thing that actually holds your web pages. This is the application, it sits there, it doesn't do anything. So those are called views and clients. So we would like to create a client, which means we need to implement a CEF client, and it asks for quite a bit of overloads, one of them being on process message received, which is the process message we sent before, where we have the browser that sent the process message, the PID from where it came from, and the actual message itself. So when we want to instantiate our client, we create a window info and set in this thing here. I'll tell you what this is in a little bit. We create settings for the browser where we want JavaScript enabled. You can actually turn it off. And this thing here is pretty big. You can turn on WebGL. You can turn on, basically, if you go into your Chrome instance and you have your settings list, this is basically it. So it's a pretty big settings list. So I just show here, yeah, I want JavaScript enabled because that's what I'm doing. And then I create a browser with the window info. My client is just an instantiation of this guy. The URL, which I wanted to point to, the settings file, and I don't remember. I'm sorry. I should have checked what this one was. But there's an important point here. This is a window handle. And this is just Windows' window handle. Here we are creating whatever MSDN says we have to do to create a window with all their options and all their thingamabobs. So if you want this to work in OS X, you would have to create that kind of window and give CEF that handle. If you want this to work on Linux, you have to create a window there and give him that handle. So this is OS specific. Okay. Let's then implement this on process message received. again, we have a browser, we have a source process, and we have the message. We get the name of the message. We get an argument list. We ask, is this the Uplay UI message? Just to make sure that nothing else is being executed. And now, what we have here is the actual data that we want. We have the name of the message, in our case, message download game, and argument 1 is your JSON string, if any. So from here, we are free from CEF. Whee! If that's your object. You can send this to any kind of abstraction that you have. So that's what we do. For our views, we have for the client, we have a view. We create a thing called message from UI, where we give it the message struct that we want it to turn into. And then we have what the message is as a string. So we map these two together. And what this message from UI function is actually doing is it takes a type name t, takes the message name, and then we have a map of the strings, which are the message names, and a function called dispatch message on t. So we bind it on t when we place it back into the map. So now we have registered a list of callbacks based on the name of the message. So for message download game, we have a callback for message download game on dispatch message, with the T being message download game. So when, if I go back to this, when this happens, I can send this off using any means I want to this function here, or this instance there, and it will look up the message name because we have that as the first argument, and it will call dispatch message. We can call dispatch message. And what is dispatch message doing? We have some JSON parsing in between, but then I have the JSON value. I have the T because it was defined when I registered the message. So now I can instantiate T, which is the class itself, which is then the class message download game. I can then call from JSON on that class, which they all should have, with the JSON. If that doesn't work, for some reason, it's a mal from JSON, we just go away. We log it here and all that stuff. Otherwise, we dispatch it out to our message dispatcher, which I'll go in a bit. So this has been quite a mouthful. So let's summarize this. We have an application handler. When it's created, it allows us to add a C++ callback to the global object. When that global object callback is called by the JavaScript code, the send message, it runs the V8 execution handler we gave it. That notifies any user-created clients that a message has been sent. We unwrap it and find out what message it is. And then we call our user-defined from JSON functions to deserialize it. So it is, as I said, it is quite a bit of code you have to go through to get this, but this has been working pretty well. And so well that I actually had to go through and read this again to figure out like how was this structured. Because when we created this initially, it was just created and then we forget about it. It's a system that now just works. So what is a message then? Well, a message is just a class, empty class. We have one thing on it, which is really helpful. And here you see it used to not be const_expr first. It just used to be const, and now it is const_expr, which is really nice. But it's just a type index of the type T. So we have a type index function, which is quite handy. But most messages are JSON messages. So a JSON message T is a message T, and they all have overloadable to and from JSONs. If you don't want any to from JSONs, you don't do anything, because then he'll just say return true or return an empty string. So if it's a message with no data, you don't have to do anything, which is nice as well when you implement things. So message download game is a JSON message download game. It has a uint32 of game ID, and then it has its own overloaded from JSON, which takes the JSON value. And that function, whatever JSON unwrapper library you have, you can just ask, hey, is there a game ID here? Give me a UN32 of that game ID, set it here, and then return true. Again, I have removed checking code, and you'll see that in a bit, what that checking code is. So, the last bit of the puzzle. Really going faster than I thought, which is great. So what is this MG message dispatch? So if there is anybody who is interested in a message, they can create a callback, which is just a bind of, let's say in this case, it's the download bus. It has a function called message download game. It's a shared class, shared pointer class, so we have a weak pointer to it. And then we have a bus where we add this callback to the bus, saying, here is a callback that is interested in when a message download game comes in. And I'll show you, it's kind of a neat trick. I don't say message download game, the message name itself, anywhere here. But you'll see how that works in a bit. And this is a lovely hack to get the ID of the recipient. So, add route. So here you have, because it's a callback of void const type. Here I've grabbed the message download game argument. So by just sending in the name here, I have no idea what actually is the message. I've grabbed it because you have to fulfill this interface to be able to compile. So here I have the type, I have the receiver ID. We create a route of the type. Route is just a small helper function that just stores both the callback and the receiver ID, and it has one utility function. And here you can see the utility of the get ID. So get ID on a route is just calling get ID on a message, which is the type index of the message itself. So I've created a map of where the index is the message itself, and then I push back the route. So now I have a list of the callbacks of anybody who is interested in messages of this type. Because I have the message type here, and then I have a list of all the callbacks. I mean we. So when that message comes in, it actually ends up in the same bus calling this priv dispatch message, which is the message type. So this thing here actually expands basically into calling this function here. So we have a message that we want to send because we sent it in the message dispatch macro. We get the ID, which would be the same type ID. Do we have anybody who is interested in it? If not, sad, but okay. But okay, we have somebody who is interested in the message. Let's loop through all the routes. And dispatch is just calling the callback in route. So this is basically saying mg callback, call the callback. So we send in the message and say, so call all the callbacks of anybody who is interested in the message. You good? Good. So these are all broadcasts, as you could see. I send the message out, and anybody who is interested in can register. Doesn't matter where they are in the system. I can say, I would like to register. Even if I'm a short-lived instance of some class, I could say, I would like to listen to this message. Message comes in, I'm an interested party, I get the message. But what if you don't want to broadcast the message? We would like someone to deal with the message, and then only me gets the result back. So we also have types called queries and query responses. And they are basically just messages, defined the same way, set up in a very similar structure. But when they are instantiated, they get a unique ID. It's a random number, which then means when someone sends a query out, I sent the query, then only I am interested in, or I am the party that should be the recipient. And that's where the recipient ID also helps. So when a query response is created, that message is only sent to the originator. Okay. Oh, this is only sending messages to the C++ backend. What if we want to send messages back up to the JavaScript? It's different code that handles it, but thankfully, it's very similar. It's a very similar base structure. It's a very similar flow. We have the toJSON function, as you saw before, so we can take a C++ struct, have a toJSON on it, it serializes into a string, we can send that out. And CEF allows us to create JavaScript code that executes in a view. So we can create a function that calls another defined function. So it's kind of injecting it up into the view. So, puzzle done. There we have it. We've gone from a JavaScript object into a C++ function being called automatically when that JavaScript object is sent out. So, there are upsides and downsides to this. Here we have complete decoupling of messages and recipients. There's no connection between those, which allows us to refactor systems and UI since all actions are abstract messages. It also allows for very simple mocking of data or actions, since anybody can send any message at any time. And since anybody can send any message at any time, since anybody can send any message at any time, this allows for testing as well. And we can then record messages as well, since any user action is a message plus time offset. Clicking on the download button we can record that message since it's just JSON data, and then we know what's the time offset since you click that. If clicking download would then give you a menu, and then you click next on the menu, clicking whatever the action is next, accept license agreement or say that you are okay with this download folder, that's another message with another time offset. So we can basically record all your actions in the client and then replay them. So, downsides of this. We have a lot of messages. We have about 860 JSON messages, and we have about 250 non-JSON messages, which are messages just sent in between C++ systems. Because we use this also to communicate from one kind of business logic to another. There could be the system that is downloading a game. It is a whole bunch of classes doing a lot of logic, and they're downloading the game, and they're saying, hey, okay, here's your download progress, here's your download progress. That could be sent to all sorts of recipients. We can have that for analytics, that could be sent to the UI, that could be sent to wherever. So if you would like a bus to listen to many messages, you have this, and it goes on and on and on. Thankfully, we try to abstract these. So here's the download bus. It's not much longer than this. It's like one more page. Then we have a user bus. We have a etc. If you have a view, a CEF view that would like to listen to many messages, like, hey, I have this friends view. I would like to have all these friends messages coming in. Yeah, you have a lot of messages that you had to register. And as for fun, I took a screenshot of who here uses Visual Studio? Yeah? Who here uses the map scroll bar, where you can see the code, like a picture of the code. Yeah. So this is a wonderful screenshot of just the registers. This is about 400 of them in one of the views. So this can go on a little bit. So you can see that if you have a class name here and then a string here, you can have mess ups. You can have the class here and then mistype the message here. So that's not the greatest. So let's then look into the future. We are moving to TypeScript with all our UI code, slowly. This means that we can strictly type all the data in UI. And as you saw with the message in the beginning, I just said var message is a 2 curly braces, and then I just said message.myGameID is some game ID, and then I sent it off. There was no checking, no anything. So yeah, what if I forgot to add a member? What if I misspelled something? There's no checks for this. So it's great that we can strictly type everything. So we've started to define all those 840 messages in the UI slowly. But you might say, wait, isn't that code duplication? You have your defined C++ message here, and then you're going to go to the UI and you're going to define the same thing there. Well, yeah, it is. And then you also have the same issue of, I defined this C++ class with some members, and then I have to go to TypeScript and define something there, or if there's a mismatch. You have to go through those 840 messages and check them all. So no. So we created a message generator. We defined a structure. We say this is a UI message. It is called game options in-game state updated. I picked this one because it had nice members. What it is doing is it's defining both at the same time. We say that my game ID has to be there. This is the TypeScript type, and then we have the C++ type. Then we here a boolean, bool. So we have a game ID, and if you can apply the options or not. And what this ends up as is that we have a warning. No, it's fine. Yeah. This then generates the C++ class for us. And since we said this one is required, we can create the constructors. We can also have the empty constructor if we want. Here are the two types, and we have the from JSON and to JSON. And this is again just a JSON message. So here is the from JSON, where we can also say, because it's required, you have to have the key, otherwise you return false. And then we have a general extract, which knows that because I sent in an int, it's going to try to extract an int and fail otherwise. And here's a bool. Because I sent in a bool, it's going to run the bool extract overload. And on the TypeScript end, we generate this guy. A little simpler. There is a little bit more code in another place where you have to register that this is a type that exists in your system so you can import it in TypeScript. So that's also a big file of types, but that's all now automatic. So we don't have to do this. So it's one definition of a message, automatically generated a to from JSON, fewer accidental mistakes, but future, we're not that far into the future. We already have this message generator, and the recently released Animus control panel for Assassin's Creed Origins was written using these new style of messages. And it looks like this. Cool? You have a lot of sliding knobs. So this was then implemented using the messages. So if you change any of the settings and then click apply, which is, you have to scroll a little bit to click apply, one of these messages is sent down to some handler in the C++, and then he accepts it and does whatever logic has to happen, which is usually, in this case, I think, save it to a file, which then the game reads. Okay? Thank you very much.